Hello everyone. So let's now solve practice assignment week 7 question number 3. Which of the following options are true? Let's check for first option. V equal to R2 and a function defined as from V cross V to R like this. So we have a function which is defined like this. Xi yi. So this will correspond to x1 y1 plus x1 y2 plus x2 y1 plus x2 y2. Now we have to check whether this is a valid inner product or not. For any function to be a valid inner product, it should satisfy four criteria. That is, one is positivity, that is inner product of a vector with itself would be greater than uh, 0 and will only be 0 when x1, x2 is 0. So this is the positivity condition. Second is symmetricity, that is inner product of x1, x2 with y1, y2 the same as inner product of y1, y2 with x1, x2. Now third is bilinearity, that is inner product of x1, x2 plus y1, y2 with z1, z2 the same as inner product of x1, x2 with z1, z2 plus inner product of y1, y2 plus z1, z2. And there's one second part of bilinearity, that is inner product of c times x1, x2 with y1, y2 the same as c times the inner product of x1, x2 with y1, y2. So if any function satisfy all these conditions, then it is an inner product. So let's check the condition 1, that is positivity for this inner product. For that, consider the vector v to be 1 comma minus 1. So inner product of 1 comma minus 1 with 1 comma minus 1 based on the given function condition would be, let me just copy. So this is our inner product definition here. So now with this, if we check this inner product, it would be 1, then minus 1 plus 1. So it is giving us 0, while our vector itself is not equal to 0. So this condition fails. Hence, this is not an inner product. So the first option is to, as it said, it is not an inner product. Now the second option, V equal to M2 to M2 cross 2, which is a matrix of order 2 cross 2, and two inner products are defined, and a function defined as which is the sum of these two inner products is an inner product on the vector space V. So we have to check. Again, we will be checking all those four conditions. So let's check the first condition. Now our uh, inner product is defined as 1 plus 2. So if we check for the positivity, now we are talking about matrix. So that means where A is a 2 cross 2 matrix, then this would be with A 2. Now it is given that the function 1 is an inner product and function 2 is also an inner product. That means this quantity would be greater than equal to 0, and basically it would only be 0 when A is 0 matrix. Same for the second function also, that it would be greater than 0 and will only be 0 when our matrix A is 0, and as both of them are positive, so we will only get a positive quantity and we'll get 0 only if both of them are 0. So that means the first condition is satisfied, that this will always be positive and will only be 0 when our matrix A itself is 0. Now let's check for the second condition. The second condition is about symmetricity. So that means if we take two matrices A and B, yeah, inner product would be this, and the symmetricity means, now we know again, as function 1 and function 2 are the inner product, so that means this would be symmetric to this. So means this quantity here is equal to this, while this is this quantity is equal to this. So this will result, both of them will result the same. So the symmetricity is defined here. Now let's check for the third condition, that is the bilinearity. So consider three matrices A plus B and C. All three are 2 cross 2 matrix. So this should be, now again as they are in a product, so we can write it as like this. A comma C2. Now if we just rearrange these terms, now this will give us uh, the function as A comma C as our here, just how our function is defined. So based on that, it is the inner product function 1, inner product function 2. So this would be the inner product function, and similarly here this will result as, so as we can see that uh, the third condition of bilinearity is satisfied here. Now there's the second part of bilinearity, that is the constant. So let's check that also. Now let's say we are taking any scalar s that we are multiplying with matrix A, then this would be, here s is a scalar. Okay, so S here belongs to R, while A and B are 2 cross 2 real matrix. So now if we expand this, as this is an inner product, we can write it as, again this is an inner product, so we can write it as, and we can take the S common from this, so we get, now this quantity here is nothing but AB. So we have satisfied the fourth condition also. So as all the fourth condition are satisfied, so this means it is an inner product. Now the third option, now V here is our 3 cross 3 matrix set, and again we are defining two inner products, and the function defined as the difference of these inner product is also an inner product that we have to check. So let's check for option 3. So here our function is defined as the difference of to inner product. Now, if we take, let's say, for any case where this inner product results the same value, that means for any case where inner product 1 gives us the same result as inner product 2, then in that case, the function that is defined as the difference of these two inner product will give us the result 0. Uh, this will give us 0 for any matrix A belonging to set V. Uh, Whether it is a 0 matrix or not, it will give us 0. So our first condition would not be satisfied in that case, so it will not be an inner product. Option 3 is false. Now last option, V is R2, so we are defining a function as x1 y2 minus x2 y1. So option 4, x1 x2 y1 y2, and it is defined as x1 y2 minus x2 y1. We have to check whether this is an inner product or not. So let's take an example of 1 comma 1 with 1 comma 1. As it is an inner product of vector with itself, it should be greater than 0 as the vector itself is not 0. Let's check. It would be 1 minus 1. That would give us 0. But as the vector itself is not 0, so that means our first condition is not satisfied. So this is not an inner product. While option says it is an inner product, so wrong. Thank you.